Online. Before you is teacher Mugulumiza Noah, a mathematics educator. Now, today I have brought very interesting news that mathematics is one of the simplest subjects, though much of the times students tend to take it as one of the hardest. Now, I'm just here to resolve that issue. Mathematics, I repeat once again, it's the simplest of all, as we are going to see. Now, I'm basically going to use a scenario and we see how we can redigest mathematics questions. Please follow and share. Subscribe and share online on YouTube, TikTok, and the other platforms on online. Now we have a question at hand. We have a question at hand that we are going to handle, as you can see it there. I will also go through it and we see how we can handle such questions. You can see it clearly. This is a complete mathematics item, and we all know that what we call an item, it encompasses quite a number of topics, and that means as a mathematics learner, you are required to, one, equip yourself with the knowledge of at least all the topics, such that when you are reading the scenario or the item, you are able to really tell which topic is the scenario coming from. When you get to know the topics that are in the scenario, then you can ably digest the question. Okay, let's now look at this question clearly. We have a man wanted mangoes from a mango tree, which he's seen at different positions. The man who is of 1.5 meters tall was 20 meters away from the mango tree, where he had seen the mangoes at an angle of elevation 35 degrees and 58 degrees respectively. That is now a scenario. Someone wanted some mangoes, but was standing at a distance 20 meters from the mango tree. Then he saw two ripe mangoes at two angles of elevation, one at 35 degrees and then the other at 58 degrees. Okay, that is part one of the scenario. Then a continuation, during a charity organization retreat, members wish to construct right pyramid tents. Each slant edge of the tent was to be 6 meters, where the base was rectangular of dimensions 4 meters by 3 meters. So the task that we have as mathematics students, one, help the man determine the height of the mango tree and hence the distance between the two ripe mangoes. B, help the director of the charity organization determine the angles between the slant face and the base, also the height of the pyramid. Then C, how much money would be spent on a cloth to cover the tent floor if 1 meter squared costs Yugi shilling 5,000. So let's handle this question with ease. First and foremost, before we begin the calculations, when you read through that scenario, we see that it has some topics in it, among which we have trigonometry 2, trigonometry. There is trigonometry there. At least it is not a D, either 1 or 2, but trigonometry is there. This is topic, the trigonometry is studied in senior 3. So because of the angles of elevation and depression, so it takes us to trigonometry, not bearing. Now, we've seen there are some issues to do with tents. A tent, when you look at the structure of the tent, it has the length, width, and then it has the height. That means it has three length or sides. And that takes us to a topic called three dimension in senior 4. So we have now two topics, trigonometry, then three dimensions in senior 4. Okay, let's now first handle part 1. Now, part 1 is requiring us to find the height of the tree. Then we are also required to find the distance between the two right angles. I have just come up with a simple sketch. This man is of height 1.5 meters, as you can see. But when this man stands, assuming before he looked up to see these mangoes here, because there is a mango here and another mango here. So before this man looked up this tree, there is what we call a line of sight. This one, this dotted line, you can call it line of sight. Line of sight. The line from his eyes up to the tree. We assume there is an imaginary line here. We can call it line of sight. Now, this line of sight, when this person looks up, in mathematics trigonometry, we have basically two words that we use. We have angle of elevation, and then we have angle of depression. To elevate, that is to look up past a line of sight, then angle of depression, it's when you just lower your eyes like this below the line of sight. So according to the question, we are given angles of elevation, but there are two. One is 35 degrees and then the other one is 58. So 35 is from here, from the line of sight up to here. Then the second one is from the line of sight up to here. That means the first mango was here. This is first mango. Then the second mango, we are going to assume it was there. Then finally, we are required to find the height of this tree. Now, mathematically, if this man is of height 1.5 meters, then automatically, even from here up here, it will be 1.5 meters because this is also equal to this. When we try to extrapolate here, or when we try to come up with something rectangular, you see that this side is equal to this side, and this side is also equal to that side because they are opposite. So that means if here, this man is standing 20 meters away from this mango tree, even from here up here is also 20 meters. Can put it there. Then the height I've represented it with capital H. That is from the ground up to the top. This is the height of the tree that is required. And then there is also this distance from here. We can actually represent it with the smaller d, the distance between these two ripe mangoes. Okay. Now, we are first of all going to use trigonometric ideas or trigonometric ratios to come up with the distance from here, from the line of sight up to the first mango. After getting that distance, we also get the distance from the line of sight up to the second ripe mango. Then when we get this distance from here up to here and the distance from here up to here, we can now obligate the distance between the two ripe mangoes, and we shall simply subtract this distance minus that and we get this distance. Okay, let us go calculation. So we are just going to come up with under our solution. I'll first extract a simple triangle here. This simple triangle, I'm going to first consider this angle of elevation at 35 degrees. So my 35 degrees are there. Then from here up to here, which is the adjacent, it is 20 meters because we've said that if here is 20, also here is 20. So then this side where the angle is facing, we are going to call it opposite. This is hypotenuse, then this is adjacent. When you have a triangle of this format, like this, of this format here, and you have, say, maybe an angle theta here, the side where the angle theta faces becomes your opposite. The longest side is hypotenuse, then the remaining one is adjacent to this angle. So, when you look at my sketch here, 35 degrees, its opposite is O, the hypotenuse is capital H, then the adjacent is 20 meter. So I'm just going to borrow an idea from the trigonometric ratio. I'll simply say recall from SOHCAHTOA. SOHCAHTOA. Now, SOHCAHTOA is just a mathematical phrase that enables students to recall which formula to use when they are handling things to do with trigonometry, or when you are handling trigonometric identities. We all know that when I say SOHCAHTOA, S becomes, or S stands for sine, then C becomes, or stands for cosine, this is sine, and then T becomes, or stands for tangent. However, these are all abbreviated as sine, cos, then tan, but their full forms are tangent, cosine, and sine. Then these two second letters on each, the OH, O is opposite, then H is hypotenuse. That means if you are using sine of an angle theta, then the formula for sine theta becomes opposite over hypotenuse. The first one is the numerator, the second letter is the denominator. Then for cos of the theta, this second one, AH, it is the adjacent over hypotenuse. And finally, tan of the angle, tan theta, is given by opposite over adjacent. So when you try to summarize all this, you can just come out with the mathematical phrase that SOHCAHTOA. So now, this SOHCAHTOA is very, very vital in our mathematics calculation. So you have to know which one to use. Of course, in a calculation, you don't just use any, because we have three. We have the sine, cosine, and the tangent. But you don't just use any. You appropriately apply the one that suits the question. Now, let's look at the question. When you look at this question here, we are basically interested in getting the height from here to here. And case in a point here, this is the opposite. So this is opposite, then we have the adjacent. That means there is no need for me to get the hypotenuse because it's not required. I'm only interested in getting this height, and this height, according to my extract here, it is the opposite. That means I just put here the 20 meters, it is adjacent, then this is O that I want to find out. The angle is already given, theta is given. Theta can be any angle. Case in a point, the 35 degrees. Now you come in the formula, you already have A, but you want O. So you look at the following, SOHCAHTOA. Which one? You have two letters, you have O and H. So you have A, but you want O. So you come and look at, is it sine that has OH? Now, when you look at sine, it has OH. And we've said hypotenuse is not required in this question. So we disqualify sine. So we go to cos. When you look at cos, it has also hypotenuse. And we are not interested in hypotenuse, getting this length. So we also disqualify the cosine. Lastly, we have the tan or the tangent of this triangle. So this tangent has the opposite and the adjacent. So we want to find the opposite, but we already have the adjacent. That means tan is the best trigonometric ratio to use. We call it a ratio because it is unitless. When you find sine or cosine or tangent of something, never tamper to put that in a unit. It is unitless. By definition, these are ratios. So a ratio must be unitless. Let's go back. So we've discovered that the best trigonometric ratio here to use is tan. So we shall simply say tan theta, outside theta is any angle of right angled triangle. So tan theta equals to opposite over adjacent. Now when you look at our triangle here that I've already extracted here, this right angled triangle, the theta outside it is the angle. So the angle is 35. So where I have theta, I'll just say now tan of 35 degrees is equal to opposite. Opposite is what I'm looking for. Case in point. Now to differentiate it, because I'm going to find the different distances, I'm going to call this O here, the opposite. I'm going to call it distance 1. So D1 over adjacent, but my adjacent is 20 meters. So when we cross multiply, we shall have D1 giving us 20 tan 35 degrees. D1 will be equal to, those with calculators, when you place 20 tan of 35, you get 14.004, and D1 you can approximate it to 14, but these are meters. These are meters because we are dealing with distances. Now, after getting D1, we are now going to get another distance from here up to here, from the line of sight up to where the second mango is. So I'm going to say similarly, then I resketch this now, like this. Now, this time around, the angle of elevation is different. This person, again, he raised his head like this, and that means the angle of elevation had to change. And the new angle of elevation was 58 degrees. So where we had 35, I'm now going to use 58. So this is 58 degrees, but of course the adjacent is the same from here to here, and that is 20 meters. Then the opposite, I want to call it D2. Now, it is the same situation, so I'm just going to say from tan theta equals to opposite of adjacent, so my tan of 58 degrees will be equal to opposite, which is D2 over 20 meters. So my D2 will be equal to 20 times tan 58 degrees. My D2 will be equal to my D2 becomes 32.006, which is approximately 32 meters. You can now see the discrepancy. D1 was 14, then when this person raised the head, that means the distance also had to increase, and we have 32 meters. I'm putting in meters because the rest of them were in meters. And distance, this is D2 or D1, these are all length, and the SI unit of length is in meters. However, if the man's height was given in any other unit, like maybe centimeters or any other unit, still express these distances in line with the man's height. But since the man's height was in meters, so we also need to put our different distances in meters. Back to the question, they want us, one, find the height of the mango tree. Two, the distance between the two ripe mangoes. Let's first have a flash on our diagram. The height of the mango tree is capital H, and that is from here to here. So when you look at this critically, you now see that if I add 1.5 from here to here, I now need the distance from here up to here. But the distance from here up to here, it is D2. When you look at my question, it is D2, that is from here up to here. So I'm just going now to say, I'm still answering part A. This means that height of the tree, capital H, is equal to 1.5, which is the height of the man, plus D2, which is from the line of sight up to the last ripe mango. So we say now H equals to 1.5 plus D2, which is 32. All this is in meters. So we happen to have our H as 33.5 meters, like that. Finally, we are going to also find the distance between the two ripe mangoes. And that is simple. According to our diagram, we've denoted that distance between the two ripe mangoes with a small d. So we shall now say distance between two ripe mangoes. In mathematics, it is really very good to write some statement that can tally with your working. If you simply just write, then someone can just get lost. So it is incumbent upon you to make the examiner follow your work. So the distance between the two ripe mangoes is denoted by D on our diagram, and this equals to D2 minus D1, just when you look at that. So my D is equal to D2, which is 32 meters minus 14 meters. Now, when you look at that, we happen to get 18 meters. That is the distance between the two ripe mangoes. That is part A of the question. Now, I hope everyone is following. The scenario is not yet fully attempted. This is the first part of it. I've told you earlier that a scenario incorporates different topics, among which now, when you look at this, we have trigonometry, and I have digested it to its end. Now we are going to look at the other second part, where a certain organization had a retreat. Then members had to build some tents. They gave us the different dimensions of the tents, and they want us in part B to find the angles to which the slant sides were making with the base, and also to find the height of the tent, and lastly to find how much is required to buy a cloth if 1 meter squared costs 5,000 UDX. Okay, let's now handle that. Subscribe to Moto Online. Many scenarios will be put here with experienced teachers, tested and trusted. Okay, now when you look at this part 2, that during a tent organization retreat, members wish to construct right pyramid tents. Each slant edge of the tent was to be 6 meters. Where the base was rectangular of dimension is 4 by 3, all in meters. Okay. Now, from senior to work, when we talk of pyramid, I assume you all know. So I'm just first of all going to come up with right pyramid tents, a sketch of it. Then we see. We fill in what is given, we find out the unknown. Mathematics, we tend to infinity. So let us now sketch it. I will have, since it is rectangular, I'm just going to draw a rectangular base. But this rectangular base is drawn in this format. It is as if it is a shared. When I talk of a shear force, one side slides past the other. So this is my rectangular base. Now, a pyramid, it has this base. It can be square or rectangular. But according to the question, it is rectangular. And it is of dimension is 4 meters by 3 meters, like that. Then there is always a point where we have these slant edges or the threads from the top. So these threads here, they originate from a common point where we can call it the vertex. They all originate from the vertex of this pyramid. So this is the vertex of the pyramid that I've made here in a thick chalk here. Now, this point I'm assuming it is the vertex of the pyramid. So I'm going to get one slant edge to move from here to come to this end. Another slant edge from here up to here. Another one from here up to here. And another one from here up to this one, like that. Now someone may ask, are these slant edges equal? The answer is yes. Much as you see that this is longer than this, or this is longer than this, they are the same. Only that I have drawn this right pyramid showing you the base such that it can clearly be seen. But just get your book, get a book, get 4 strings of equal length, then tie one or tie them at the different edges of your book. Then you hold them at one point up. That is exactly what we are talking about. That is the pyramid we are talking about. That means when you hold those strings from the vertex, there is a distance from the middle of this book up to the vertex, and that is the height, then let me show it here. If this is the center of my rectangular base, then the distance from here up to the center here, it is the height. You can even call it h. In the question, this h is required to be found, and they've told us that the slant edges, they are each 6 meters. So this is equal to this, is equal to this, is equal to this, but it is not equal to the height. The height is different, but these slant edges are the same. This is equal to that, is equal to that, is equal to that. 3 dimensions. Okay, now they want us to find this height here. So we are just going to critically analyze this figure, how we can figure out and come out with this height. It is very easy to come up with this height if you form a right triangle. Why do we need right triangles? It's because when you get a right triangle, then you can either use the trigonometric ratios given the angles, or you can now just use the Pythagorean theorem that you already acclimatized with. So now, let us first extract a simple triangle, and then we see which one to use. Okay, now, when I look at this, it automatically means that already I have a simple triangle. There is this slant edge here, then there is this height here. So what is remaining is now me to join from here up to this corner. Now when I join this like that, have formed a triangle here like this, and already here is 6 meters. But for you to use Pythagorean theorem, which is a squared plus b squared is equal to c squared, that means you must have at least 12 of these sides, and then you find the other. If you only have a, you cannot find b, or you cannot find c. So that means we need to get another side. That means if I need height, I must be with this one and this one. That's in a point, this is now the hypotenuse because it is the longest side. This is the height, and then this is the base. So, but you look at this one, the base of my triangle. If I increase it to this point here, it becomes a diagonal. When I, actually let me put some namings here. This is V, I can put here O, origin, then A, B, C, and D. It is okay to name or to label your diagram as per your wish. Now, when you now consider, initially it was a rectangle A, B, C, D. Now, when I draw a diagonal AC, I have simply got another triangle ABC and another triangle ABC. So I've got 2 triangles. So why have I again gone an extra mile of doing this? It is because when I get length AC, since it's a diagonal, then I can able get AO, because AO is equal to OC. So if I get AC, then AO is a half of O, is a half of AC. In other words, when you get AC, you just divide it by 2 to get AO. So when we get AO, then we shall have got this B here, and then we can punch in our formula of Pythagorean theorem. So I'm just going to say that from which rectangle? From triangle ABC. This symbol here represents a triangle. So from triangle ABC, that means you have to write it there, don't just draw. I told you that mathematics, you have to write a statement that can at least make the examiner follow your work. So from triangle ABC, you can actually go ahead and sketch it. This is triangle A, B, and C. Now we have already dimension is 4 meters, 3 meters, and in all, you don't have it. So we are just going to say, recall that A squared plus B squared is equal to C squared, or base squared plus height squared is equal to hypotenuse squared. Anyway is a way. So we now say 4 squared plus 3 squared should give us C squared, but our C squared, it is now AC. but all this is squared. So you realize that this and that is 16 plus 9, giving us AC all squared. And when you make AC squared, this gives us 25, goes with the calculator. Then AC all squared is equal to 25. You take the square root on either side. That goes with that. I repeat, when I say this goes with that, don't cancel. In my previous videos, I said when you cancel, your work looks untidy and it looks very poor. So don't cancel. Leave your work neat like that. Show me it as cancelled. So that means we just have AC giving the square root of 25. But remember, you were told in senior 2 that the square root of a number is either positive or negative. Then the square root of 25 is a 5, like that. You have to first show that plus minus. When you simply say AC equals to 5, it is mathematically wrong. Why? The square root of a number is positive or negative. However, in this part here, we are going to only consider positive values. So you now say AC is equal to 5 meters. So you first write plus minus 5, then you finalize with a positive value. Why do we write plus minus? It is because the square root of a number is either positive or negative. So we have got length AC. Now we go back. We need to get length AO, because when we get length AO and OC, AO is equal to OC. So when we add OC plus AO, we get AC. So that means we shall simply say AO is a half of AC. We just divide the AC by 2 from here to here. So my AO will be equal to a half times 5. So when you use a calculator, our AO will be 2.5 meters. Okay, not yet done. We move to infinity. So now that, remember my question, or our question requires us to find the height of the tent. And here is the height, capital H. So we have the 6 meters, and at least we now have this part here, which is now 2.5. So it's now a matter of substituting in. So we are going now to say from or consider. This time around you say consider. You are telling the examiner to follow your work. Consider triangle AOV. Then, not only that, you can go ahead and sketch it for him. So AOV, this is A, O, and V. So AV is 6 meters. OV is the height that is required, height of the tent. Then AO, which is half of AC, 2.5 meters. Then you can say, recall that A squared plus B squared is equal to C squared, where C is the hypotenuse. So that means in this time round, we don't have the H. So I'm just going to say 2.5 squared plus H squared is equal to 6 squared. Now, when you have that, when you have when this crosses the other side, of course, before it crosses, you can simplify this anyway. Here you get 6.25 plus H squared, giving us 36. So this will traverse to the other side and we remain with H squared, which will now be 36 less 6.25. Our H squared will now give us a value which is 29.75. But this is still square, so we need to take the under root, the square root of everything on either side. So we take the square root of each such that this cancels with the other. So when we take the square root of 29.75, our H will become plus minus. First write that plus minus because this is a square root. We get 5.4543 when you use a calculator. Then that means you can now write the positive one as 5.4543 meters. You conclude the height, therefore, the height of the tent should be 5.4543 meters. Now, the last part, or the second last part, is asking us to find the angle is asking us to find, that is part B. We are still on part B. The height is already found. Now, the second part, still in part B. They want us to find the angle, the slant edge, these slant edges. I told you that these slant edges are the same, but I'm only basing on this one. You can base on any edge, but me, I'm basing on this. So, this is the slant edge. Then we have the base. The base is A, B, C, D. That is our base. So they want us to find the angle which is made by the slant face. The slant face is AV. And then they want us to find the angle this AV is making with A, B, C, D. First of all, we have two things. We have a line and a plane. A plane is just a surface. This is a surface A, B, C, D. It is the base. Then AV is a line. Now what you need to do, you first recognize something similar here. We have AV, A, B, C, D. Now, when you recognize something similar here, there is letter A, letter A. That means the angle at least should be based on letter A. So angle should be around A because AV and ABCD are sharing something common, which is A. Now this is the angle that they want. We have this slant face, then the base ABC. Now this plane here, I'm just going to consider the middle of it, that from here up to here, then for someone to get any angle, you have to do with a triangle. So we are not still going to consider triangle AOV. And this angle that is required, it is here. We are going to call it angle theta. You can even call it any angle, theta, gamma, beta, sigma, any sort of letters that you love. So we want this angle now here. The line AV or the slant edge, and then this is the base ABC. But the base ABC, we cannot finish the whole of it. So it is from here to the center. Then we just get the height such that we form the triangle, and then we get this angle here. It is very, very simple, as we can see here. So we shall now say angle between AV and ABCD. Then I'm going to say from triangle AOV. Then when I sketch this triangle, it is of this format. This is AOV. AV is 6 meters. AO is got as 2.5 meters, and OV is 5.4543 meters. Now, they want us to get angle. I have nicknamed it theta here. Now here, we have quite a number of ways that we can use to come up with the right answer. To those that are familiar with the cosine rule, they can use it. We state that A squared is equal to B squared plus C squared minus 2BC cos of A. But however, according to this level, it's a little bit hard for some learners to maybe understand this. So I'm just going to give you a simple format on how we can really come up with something simple other than using this. Mostly used by A leveler. So I'm going not to use this. I'm going to use the soccer tower. So I'm basically going to get the angle here, theta. But I have all the sides. So I will say from soccer tower, sine, cos, and tan. You realize that every student can use any and you still get the same answer always, just minimal discrepancy. Now, if someone uses sine, sine is opposite over hypotenuse. Opposite is here, hypotenuse is here. If someone uses cos or cosine, it is adjacent, which is 2.5, divided by hypotenuse, still which is here. Then when someone decides to use the tangent or the tan of theta, then it is opposite over adjacent. Given the fact that all sides are given, we can now use any. You can use sine, you can use cos, you can use tan. I prove you right. You can all get the same answer. If it is 36 degrees, then someone can get 36 point something, 36 point something, like that, or maybe 35.9. The difference would be very, very small. Let me just use sine. I'll now say sine theta equals to opposite over hypotenuse, just from SOHCAHTOA. So my sine theta is equal to opposite. The opposite to my angle is 5.4543 divided by hypotenuse, which is 6. So, but I want to get theta, not sine of theta. They are two different. I want to get theta, not sine. So that means I will now take the arcsine or sine inverse. Those with the calculator, you just first place the shift button. After placing the shift button on the upper left top of your hand of the calculator, then you place sine. It will bring something similar to mine like this. Sine power -1, that is the sine inverse. So when we are getting angles, that's what we do. So my theta will be equal to sine inverse. This is read as sine inverse or arcsine of this right one, which is 5.4543 over 6. Angles, you can record it to 1 or 2 decimal places. Now, when you place that, we shall have we shall have we shall have 65.4. We shall have 65.4. These are degrees. Every time you can try using the cos and the tan, and you see whether you get something similar to that. Then the other very last part of the question, that is part C. They are asking that if a piece of a cloth, if 1 meter squared of a cloth costs 5,000 Uganda shillings, then how much is required to cover the whole tent? Remember, they're just going to cover the floor of the tent, but 1 meter squared of a cloth costs 5,000. So that means we just need to get the area of the rectangular base. So we are just going to get the area of the rectangular base, which can be got here. That is part C. We say area of rectangular base. Area of rectangular base. But remember, the rectangular base is already a simple rectangle of the dimension is 4 meters by 3 meters. If we are to draw it right from that rectangular base A, B, C, D, this is a rectangle, so it is of the dimension is 4 by 3. So now we shall simply say area is length times width. So length width. So our area is 4 by 3. All these are meters squared. So our area will now be equal to 12 meters squared. We need to get how much is required. But 1 meter squared equals to 5,000 shillings. How about now the 12 meters squared, which is the rectangular base of our tent that we want to cover, will now just be equal to 5,000 times 12, but this will be our money. So we shall have shillings, 5 times 12, that is 60,000 shillings. So this organization, the director needs 60,000 shillings to buy the piece of a cloth that can suffice the rectangular tent, such that it is fully covered. In case of any question, welcome you, but that is to do with mathematics scenarios. They are very, very simple. Just take your time, identify the topics in it, then you handle them appropriately. Please do these numbers with care. These are numbers, so you have to write some statements that can enable the examiner to follow your work. Thank you. Maybe let me check if there are some questions here. Well. Fiona, you welcome. Salumo, Alwil, we also welcome. Ronnie Pay, you also welcome. Jamaima, Nalunkumaluth, you also tuned in. Luth Nabada, you also most welcome. Kati Pom, you also welcome. Mugisha Kevin, most welcome. Ethan Ahura, you most welcome. Maus Jonathan, welcome. Asime Mike, you're so welcome. Susan Lamze, you're so welcome. Joshua Joel, welcome. Lina, you're welcome. Ranjan, you're so welcome. Gloria Juliet, you're most welcome. Share it with the other colleagues of yours. So, if I try to go through your questions, if you use trigonometry, do you get the same answer? The answer is yes. I don't know which one you were trying to mean. If you use trigonometry, where? If you use trigonometry, where? Here. Okay. Now, maybe if you want to get this side AC using trigonometry, then if you have this angle here, if you are provided with this angle, then you still get the same answer. So you answered. Remember, the question is contain more than one topic. Ruth, that is true. A scenario contains more than one topic. So you have to understand all. Someone is saying, I used another one and I got 65.3. You got 65.3 something. So when you round off that figure that is next to 3, I think it is greater than 5, and the rules of rounding off have to apply. So when you apply, you similarly get 65.4 degrees. Endeavor to put degrees, please. Where you use the Pythagoras. Which one? I used the Pythagoras theorem when we were finding the remaining sides. So if you have two sides of a triangle and you are required to find the remaining side, you can use, for now, you can use the Pythagoras theorem. The other formula of cosine and sine is a little bit lengthy, and we can just use this because it is easy. Okay, I think that is all. Thanks for tuning in.